Let's look at sets in Python. So if you have taken a basic course on math, then you must have seen set theory. So there's some properties of sets that are built into Python, and they're very useful in some cases. So set is a collection of objects, right? It can be different types, and typically they're numbers, right? So one of the properties of sets is that there cannot be identical elements. So 1, 2, 2, right, is the same as 1, 2. So we'll see that if you type in with curly braces, right? Curly braces with without any dictionary type definitions are used for sets in Python. So we talked about dictionaries, right? Dictionaries are key value pairs. So the curly braces are used for dictionaries also, but if there are no key value pairs, there's just individual elements within curly braces, then it would Python would consider that as a set. So if you define 1, 2, 2 as a set in Python, Python is going to change it to 1, 2. In other words, it's going to get rid of duplicates. And by definition, order does not matter in a set. So 1, 2, 3 is the same as 3, 2, 1, or any other permutation of these three numbers is going to be the same set. And mathematically, empty sets are represented by empty curly braces. So there are two ways again to define a set. So this is typical in Python. They're usually like you can use the parentheses or brackets or curly braces to define an object, or there is a built-in function also like set. So this built-in function, right? If you place anything iterable like a string or a list within this, Python is going to convert that into a set. So so in this case, the ABC is a single string. Python converts it into a set. The other way you can define the set is by curly braces and entering the individual element one by one. So again, in Python, sets can be a mixture of anything. So this is a string, this is an integer, this is a float, this is a boolean, right? So it can be a combination of all these if you want. And about the duplicates, as I said, so if you define a string, right? So using the set function, there are quite a few duplicates. If you define this as a set, Python is going to get rid of all the duplicates, and then you just get unique elements. And this is very useful. The algorithm is built into this, right? You can design your own algorithm to get rid of duplicates, but Python. So sometimes if you wanna be quick and get rid of duplicates without going into the algorithm, then this is a really good way to do it. You can convert your string into a set and then convert it back into a string by using the join function, or you can convert your set into a list and then join it, or whatever you prefer while writing a program. So null set, so if you define a set with empty without anything in the parentheses, that's a null set. So this is an example of a set, and then this is another example. So you see that if you type one, the 1 has been typed twice and the 2 3 times. But Python modifies that to just 1, 2 because it's because no duplicates are allowed, or this is the same as that, right? So so this is another set. It's made up of a string, an integer, float, and a tuple. So so you can again, as we discussed, you can define a set as any different type of objects, right? Now, one of the things so about again the definition, order does not matter in a set. So Python is just it typically not going to maintain any order to the set. So ABCD is the same as ACBD. Okay. So again, there are built-in functions like list or strings. There are built-in function for sets also. It's just very similar to lists. other than the properties we discussed. So len is going to give you the length. If you can check if an element exists in a set by using the in operator, or you can iterate. It's an iterable quantity, so you can iterate over the elements of a set by just using a for loop. So here is an example of what we discussed right now. So this is a set, right? You can check the length of the set. It's 6. Is A, you can check if A is in my set, and that's true. It returns a true because it does exist over here. You can check if Z, right? Z is not in the set, so you get false. Now you can also again iterate over the elements by using a for loop and print each element. The end equals the separator means that it's going to be, each element is going to be separated by a spacing. By default, this is a new line, right? So there's some properties again of sets that you can use. So there is, you might have heard of intersection, union, right? Set, difference. So let's talk about that. Python has built in, has those definitions built in. So if you have, let's say, two sets, right? You can get the intersection. Intersection means the common elements between the two sets. So C, D are common elements. So if you perform the intersection, you can use the and sign or the ampersand to perform this operation. Or there is a built-in function also, dot intersection, also that you can use to calculate the intersection of two sets. Again, the order does not matter in this case. A and B is the same as B and A. Now union is just it's just going to combine everything together. So if again those two sets, and then it just again there's not going to be any duplicates. So you get A, B, C, D, E, F, right? This blue region is just gonna is the union of the two sets, and the pipe is used for union in Python. And you can also find the difference. Now if you find the difference, again those two sets again, you can you're gonna get the elements, right, from the first set, and Python is going to get rid of the common elements and also any other elements that are in the second set, right? So for example, A minus B, right, is going to get rid of these common elements, and then also this E and F, right? And this is the order matters in this case. So if you do B minus E, you get E and F, and the second set is going to be A, so it gets rid of A and B. Now there's another, so if you want to include the E and F, there is another way. You can use the caret symbol. So that's called the symmetric difference in set theory. So if you do that, then Python is also, it's just going to get rid of the common elements between the two sets, and you get everything else again from the two sets. So, and in this case also order does not matter. A caret B is going to give you the same as B caret A. And when you're talking about set theory, there's a very common thing that you sometimes have to check whether a one set is the subset of another one. So you can use the less than equal to sign, right? The Boolean operations to check that. So you can check that if you want to check the small set is a subset of the big set. So ABC, and this set is going to be ABC, D, E, F, right? So the less than equal to sign is going to tell you that that's true. It's a subset. You can see that in this picture. And then big set is a superset. That's also going to be true. Big set is a less than equal to big set. Yeah, it's equal to. So it's going to give you a true. And then this is also true. Small set is greater than equal to. Since it's equal to, then it gives you a true. And then small set is greater than equal to big set, which is false because it's a subset. Now there's some other operations that you can perform with sets, like lists. So they're very similar to lists. You can add an element, right, to the set by using .add, the .add method, and you can clear the set, make it just empty. You can get rid of an element from a set by using the dot remove method or dot discard. The difference is that the remove, it's going to give you an error if G is not in the set, whereas discard would not care. And again, if you want to make a copy, then you can make an independent or a shallow copy, as it is called in Python. You can use this dot copy method to create an independent copy of a set.